right, good morning, everyone, and thanks for tuning in today to, well, I suppose me recording this a week or two ago. And of course, I'd like to extend my thanks to the organizers of the conference for inviting me to present today on some of my ongoing research. The reason I want to talk to you today about Paralic strata is because unraveling chronostratigraphy of many plastic systems is really challenging due to erosion. However, in contrast to many shallow marine environments, Paralic environments, such as coastal and deltaic plains, have significantly higher potential to preserve chronostratigraphically significant layers such as ashes. And as the science of stratigraphy has evolved, we're actually able to correlate between coeval Paralic and shallow marine strata, which of course gives us an opportunity to improve on chronostratigraphic subdivision. And for this, we will be looking at an example from the McMurray Formation today. So, as most of you will be aware, the McMurray Formation can be found among a few other localities in the Athabasca as well as the Cold Lake Oil Sands region, where formation sits on top of paleotopographic lows on the underlying Devonian rocks. And these topographic lows are interpreted as paleo valleys, most prominent of which, of course, being the Assiniboia Valley. But my research focuses on the northeastern part of the McMurray subbasin here, which is also known as the Firebag Tributary. Now, stratigraphically, the McMurray Formation has been subdivided based on the distribution of regional marine mudstones and has been described as a series of progradational depositional units. And these depositional units are often partially, or for being honest, often mostly removed by coeval channel belts and or later incised valleys. So in contrast to many of the deposits of the McMurray Formation, the deposits of the Firebag Tributary exhibit a significantly higher proportion of the deposits of deltaic and coastal plains, specifically the deposits of peat-forming mires, which would be coals, or the deposits of some of the interfluve areas, which may form paleosalts. And in 2019, we published this paper in the International Journal of Coal Geology, in which we showcased how petrographic trends within the coal seam sitting atop the lower McMurray Formation here directly relate to and highlight the earliest transgression of the boreal sea in the Cretaceous. So if these coals actually represent relative sea level rise, we should be able to correlate them to some of the regional marine mudstones. And for that, I'd like to take you on a stratigraphic cross-section that I've been working on for the McMurray Formation in my study area. So what we see here is east to west running cross-section from A to A prime here to here. And what we can see is the fairly consistent coal seam sitting atop the lower McMurray Formation down here. But we can also see coal and paleosalt successions situated in other depositional intervals, such as the B2. And specifically the B1 is interesting because in my area, the Paralic and shallow marine strata become more intertwined, which makes it, of course, for an interesting story. And we see how these coals situated atop here are correlative to some of the regional marine mudstones here, and also to this wave revealment surface that we see here. And when I was originally writing or looking at the coal seam atop of the lower McMurray for that 2019 paper, I was also starting to notice a lot of these whitish limestone bands, which I concluded should be ashes. And for that 2019 paper, we were actually able to date one of these ashes situated here at the star, which provided the first absolute age in the McMurray Formation. So what I want to give you today is essentially sort of a synthesis of the current state of chronostratigraphy in the McMurray Formation. And for that, we will be talking about two ash beds, because they are not only situated in the lower McMurray, but also we'll be discussing one on top of the B1 depositional unit, and comparing that to some of our recent advances in detrital geochronology and maximum depositional ages, where we were finally able to publish a paper here in Geoscience Frontiers after a fairly long endeavor, and where we subdivide detrital zircon samples based on their stratigraphic position into group detrital zircon samples, and from those we calculate these kind of new grouped maximum depositional ages. So let's start by having a look at the ashes. And what we see here is the ash bed situated towards the top of the lower McMurray. And from this ash bed, we were able to extract 7 zircon total, 5 of which seem to have been volcanic in origin as opposed to detrital. And those form a really nice age cluster, the mean age of which gives us this age of 121.39 million years. You'll note the nice low error because it was dated with CA2s. And let's jump over to the ash thing at the top of the B1 depositional unit. So we can see the ash here situated in the coal seam. And here is the top of the B1 depositional unit, which is then overlaid by some of these pro-deltaic looking heterolithics of the A2 interval. And similar to the ash in the lower McMurray, we're also able to extract 7 zircon. Unfortunately, only 2 of these seem to have been volcanic in origin, but also give us a really luckily nice tight age cluster here, which has a mean age of 115.07 million years. So let's compare that to some of the results of these grouped maximum depositional ages. And when we have a look at this graph, well, unfortunately, we won't have time to talk about the details today. We see that the different calculated maximum depositional ages for lower McMurray seem to work really well with the age of the lower McMurray ash, which is great news. The ages that we calculated for the C, B, and A depositional units seem to be a bit low relative to the ages of the ash, which is not entirely surprising given the low proportion of zircon that was formed near that depositional age. However, interestingly, for the onset of the lower Clearwater Formation, depending on the different calculation methodologies, where we calculate ages of 114 to as young as 108 million years. So if we now combine all of this information, we can make some pretty simple but powerful calculations, I believe. If we look at the fact that we have, as a current thought in the literature, 7 different depositional units here, and we have ages of the ash situated at the top of the lower McMurray here, as well as the top of the B1 depositional units here. We can start to figure out that if we calculate this relative to depositional units, that means that individual depositional units correspond to about 1.6 million years of deposition. And if we extrapolate that to the lowermost McMurray, that gives us an onset of deposition at 123 million years. And if we extrapolate that to the younger depositional units, that means the top of the McMurray Formation, or the A1 depositional unit, should have been deposited at about 112 million years. Now, if we compare that to our grouped maximum deposition ages, we can still see, surprisingly, that the age interval or the age depositional units we got were too old. But this onset of the age of the lower Clearwater Formation, which does also include the Wabasca member, seems pretty reasonable at 114 to 108 million years and falls well within that range. And also, of course, compare this to biostratigraphy, which places the depositional duration of the McMurray somewhere between 130 and 100, and onset of the Clearwater Formation in the Albion at 113 million years. So I do believe that the ages that we get from these ashes and the depositional durations and the extrapolated ages does seem to merit pretty reasonable amount of confidence that the McMurray Formation was deposited during the earliest Albion to the earliest Albion. And with that, I'd like to thank you all for your attention, and of course, I'd like to thank the sponsors of the McMurray Research Consortium, being BP, Synovus, Husky, Nexon, and Woodside. And of course, if any of you are interested in some of the papers that I've been talking about today, feel, of course, free to reach out to me at any time. And with that, I'd like to open for questions. Thank you very much.